Hi everyone! In this video, we will continue example 2 from previous semester papers under homogeneous equation. Okay? Solve the homogeneous differential equation 3x cubed plus y cubed dy over dx equals to 3x squared y. Okay? So from here, we have x cubed, y cubed, x squared, and y the power of 1, okay, which is same degree 3. Okay, so we can solve this first order ODE using homogeneous equation. Okay, so when we solve using homogeneous equation, step 1, we write dy over dx as a subject and name as equation 1. So from here, okay, we can move 3x cubed plus y cubed to right hand side. So we have dy over dx equals to 3x squared y over 3x cubed plus y cubed. Okay, now we have dy over dx as a subject. Okay, and then we name as equation 1. Okay, step 2, we substitute dy over dx equals to x dv over dx plus v and y equals to vx into equation 1. Okay, then we get this. Okay, we replace dy over dx equals to x dv over dx plus v. Okay, from here. Okay, we replace y equals to vx and y from denominator also equals to vx. Okay, from here. Okay, and after that we simplify, so we have x dv over dx plus v equals to 3x cubed v, okay, and then over 3x cubed plus v cubed x cubed. Okay, right, step 3, we can factorize and simplify x cubed. Okay, notice that if we have degree 3, so means that we can simplify x cubed. Okay, if we have degree 2, so we can simplify x squared. Okay. Okay, so from here we have term containing x cubed. Okay, so we can factorize. So from left hand side we have x dv over dx plus v, and then 3vx cubed, and then from denominator we have all term containing x cubed, so we can factorize. Okay, so we factorize x cubed, so we have x cubed times 3 plus v cubed. Okay, after that we can simplify x cubed from numerator and x cubed from denominator. Okay, when we have degree 3 means that we can simplify x cubed. Okay, alright, so after we simplify, so we have x dv over dx plus v equals to 3v over 3 plus v squared. Okay, and then from here we can solve separable equation. Okay, so step 4, separating variables v and x. Okay, so when we want to separate the variables, we can follow Bodmer's rule in backward. Okay, means that we separate subtraction and addition first. Okay, so from plus v in the left hand side, okay, we can move to right hand side. So we have x dv over dx equals to 3v over 3 plus v squared v cubed minus v. Okay. Alright, from here, we standardize the denominator on the right hand side. So we have 3v minus v times 3 plus v cubed over 3 plus v cubed on the right hand side. Right? And then we expand and simplify the numerator on the right hand side. So we get x dv over dx equals to negative v the power of 4 over 3 plus v cubed. Okay, and then from here, we can move terms containing x and dx to right hand side, and we move term containing v to the left hand side. Okay, so we can move denominator dx to right hand side. Okay, and it become multiplication. And then we can move x from left hand side. Okay, and it become denominator. Okay, and we can move v the power of 4 over 3 plus v cubed to the left hand side. So we can exchange the numerator and denominator for terms containing v. Okay, so we get this. Okay, we have 3 plus v cubed. Okay, from here when we move to left hand side, and then over v the power of 4 from here. Okay, and then times dv equals to negative 1 over x times dx. Alright. Okay, after that, we continue with step 5. After we separate variables v and x, we can integrating both sides. Okay, so we just put integration sign for both sides. Okay, so now we have integration of 3 plus v cubed over v the power of 4 dv equals to integration of negative 1 over x dx. Okay, and then from left hand side, okay, we can separate the fraction. So we have integration of 3 over v the power of 4 plus v cubed over v the power of 4. Then we simplify using properties of indices. So we have 3 v the power of negative 4 plus 1 over v. Okay, and then we can integrate one by one. Okay, we integrate 3 v the power of negative 4. So we have 3 times v the power of negative 3 over negative 3 using power rule. And then we integrate 1 over v. Okay, we have ln v using ln rule. Okay, and then from right hand side, okay, we can move negative sign outside integration sign. Okay, and then we have negative integration of 1 over x dx, and then when we integrate, we have negative ln x plus c. Alright. And after that, we simplify. We can simplify 3 here and 3 from denominator. So we have negative, and then we move down v the power of negative 3 to denominator. So we have negative from here, and then 1 over v the power of positive 3 or v cubed. And then plus ln v equals to negative ln x plus c. Okay. And then we can continue with step 6. Okay. We replace v equals to y over x because the original question given in terms of variable x and y. Okay. So we need to replace term containing v in terms of variable y and x. Alright. So the general solution is negative 1 over, we replace v by y per x. Okay, so we have y per x cubed, and then plus ln v, then we replace v by y over x. Okay, and then equals to negative ln x plus c. Okay, this is the final answer. Okay, we stop here. Okay, no need to find the value of c here since the initial condition is not given. Alright. Coming up next, more examples for homogeneous equation. Thank you for watching. Stay tuned. Bye. Assalamualaikum.